Good morning and welcome everyone to our new webinar. Today we are very pleased to have with us Lorenzo Masiero, who will talk of a very interesting topic related to tourist preferences and public transport in Hong Kong. So let me now briefly introduce Lorenzo Masiero. He is Associate Professor at the School of Hotel and Tourism Management of the Hong Kong Polytechnic University from 2018. His main research interests focus on tourism behavior, stated choice experiment, choice modeling, and tourism statistics. He is a member of the International Association of Tourism Economics. He is also a member of the editorial board of the Journal of Travel Research, Tourism Economics, and Tourism Review Journal. He published in many high-quality journals, such as Annals of Tourism Research, Tourism Economics, Tourism Management, and Journal of Travel Research. Before leaving the floor to our guests, let me outline the structure and the organization of the seminar. This webinar is split into two parts. First of all, we will listen to Lorenzo's presentation for about 1 hour. Then we will have a 5 minutes break to collect the questions. And after that, we will have the question and answer session for about another hour. Live streaming is available on the GSSI YouTube channel, and people following us on YouTube can also ask questions. Let me thank in advance my colleague Benjamin Yara, who will collect for me questions from YouTube. Please keep all the questions for the second part of the webinar. I must inform you for privacy issues that the webinar is recorded. So if you have issues with that, I kindly ask you to move to YouTube. I finally remember that this seminar will be available on the GSSI website and on the GSSI YouTube channel. I think this is all. So, Lorenzo, the floor is yours. And the title of the talk is Modeling Tourist Preferences for Intermodal Public Transport. Please,
Lorenzo. Thank you very much. Thank you very much, Maria Joanna, for the introduction. And thank you for inviting me to this webinar. It's really my pleasure to be here with you today. And I will be talking about one of my current stream of research that is focusing on the relationship between transport and tourism at the destination. So this is a stream of research that I have started later during my after my PhD studies, and I'm following throughout my journey. And this specific research that I'm presenting today is part of a research grant that I got in Hong Kong a couple of years ago. So it's a research that in which I'm assisted by Richard Rankai. He's a lecturer at the Module University Vienna. So in this presentation, I will briefly go through the introduction, and then I will give you an overview, very brief overview of the context we are operating in, so Hong Kong attractions and transport. I will touch very quickly on the methodology that we are using in this research. And then I developed the research design. And then we are going to discuss two main studies here. The first one is going to analyze and model tourist choice. The other one, the second study, is a focus on explaining preference heterogeneity. I will draw some concluding remarks at the end. I was not aware of the 1 hour time. I tried to keep it in time. So the initial consideration, how all the research started. Well, when I was based in Hong Kong, I started to be more and more interested at the tourism, how tourism is consumed in urban destinations. And it's a matter of fact that tourism in urban destination concentrates in central urban areas. So this raises some discussion and debates in terms of implication. So from one side, of course, tourists are more willing to visit sightseeing, highlight attractions. So we have tourist preferences that are driving the visitation towards central urban areas. On the other hand, we have a more like a broader approach of tourism planning. So how we plan the destination and how the destination facilitate the visitation of attractions that are located in peripheral areas. This is the core of the research. So we focus on peripheral tourist attractions. Well, we know that they are much less visited compared with attractions located in central urban areas. However, we also know that when we look at the feedback of tourists that visit peripheral tourist attractions, we notice that tourists are usually highly impressed by these attractions, and they were not expecting to see that perspective of the urban destination. And this arises some contrasting element between what is promoted by the DMO, the destination marketing organizations, and what is rated by tourists. And when I'm talking about rated by tourists, I'm thinking about user-generated content. So let's think about TripAdvisor. So sometimes we have a mismatch between the top attractions that are promoted by the DMOs and the top attractions that are rated by the visitors. So in this perspective, the key issue that we are looking here is, what is the role of transport? Well, we know that accessibility often depends on the use of multiple means of transport. And typically a combination of the very familiar metro, so the very familiar metro infrastructure, and local buses. So in this context, we are looking at the connection between transport and tourism. So setting up the initial consideration, we started to look a bit more like at the literature, and we realized that the accessibility, the connection between transport and tourism happen at two broad levels. So we have the connection between transport and tourism at the origin destination level. So we have destination accessibility. And then we have the connection between transport and tourism at the local level, so at the intra-destination level. So we can distinguish between destination accessibility from the origin and attraction accessibility. Now, if we look at the previous research that has been conducted, we notice that the main focus is on the origin destination level. So there is a lot of literature on transport and tourism in connecting origin and destination. There is much less literature on the transport, of the role of transport in the intra-destination level. However, we know that there is extensive complexity in how tourists move around the destination. And we also know that the transport plays a very critical role in the destination development. In fact, if we can think about the transport as a result of the demand at the origin destination level, we know that at the intra-destination level, the demand is driven by transport. So transport plays a critical role in tourism development at the destination level. So as introduced before, tourists, when they visit urban destination, the main mode of transport that they use is the metro. And this goes without saying. It's very easy to travel around with the metro, even though we are not familiar with the local metro system. It's something that more or less we experienced in other destination, or also in our place of residence. So this, again, it's a great discrepancy between attractions that are accessible through the metro line and those that are instead accessible only by local buses, for example. So this brings the aim of the research. So we want to analyze the intermodal transport choice of tourists for peripheral attractions. So if we look at the literature in more detail, we can analyze three streams of research here. The first one looks at the movement patterns and attraction visitation. So even though there is a broad literature on origin destination level, we see that in the recent years, studies have been developed in the movement patterns at the destination. What we know is that the extent and the itinerary that tourists exercise throughout the destination is affected by the characteristics of tourists. So whether they are, for example, first-time visitor or repeat visitor, or what are the motivation of the travel. But also they are affected by supply elements. So again, as we were discussing before, so the transport network and the attraction located at the destination. We also know that the usage of public transport is typically associated with restricted movement patterns. So those tourists, those visitors that use public transport tend to visit in less extent the region. However, we know that visitors are very willing to travel farther, to engage in longer travel if this means to visit iconic attractions. So the key issue here is to try to connect the peripheral attractions with the transportation of the destination. And again, in a case study in New Zealand, has been found that there is a discrepancy between the attraction visited by tourists and those in the peripheries promoted by the DMO. Auckland, New Zealand was a case study for this, where many attractions are located in the peripheries. However, the movement patterns of tourists are mainly in the central urban area. There has been a lot of effort and a lot of attempts by destinations to try to spread the movement patterns. And in this context, an example is the development of destination cards, where they facilitate attraction visitation by offering transportation, a card that offers transportation and entrance to attraction. This has been designed and developed in many destinations throughout the world. So what we can say here is that the development of effective and reliable transport connections to peripheral urban areas is key to boosting local tourism. Now, if we turn to the usage of transport at the destination, then also here we see that there is an increasing research stream on transportation at the destination. The driving point is that, again, recognizing that transport system is a very key factor in developing tourism. In fact, the attractiveness of a destination depends very much on the transport infrastructure available at the destination. The focus here, however, has been mainly in trying to promote the modal shift. And this is mainly to reduce negative externalities of private transport modes. And we know that the major barrier for tourists in using public transport are related to lack of information and personal preferences. So from this stream of research, we can conclude that public transport at destination affects tourist experience and image of the destination. The third stream of research that we are looking in this research is the intermodal transport and the peripheral attractions. So here is where the research is very limited. So there is a need of research on tourist behavior in travel situations where tourists are assumed to change means of transport to reach the attraction. Here, the literature that has been looked at this topic is mainly emphasizing on the interchanges within modes. So mainly in the rail sector. So when we have to change train to get to the destination. And this is mainly like a research topic looking at the commuters, so people commuting to work. However, we know that commuters and tourists do have different preferences in this regard with respect to interchanges. So tourists value interchanges more than what commuters do, probably because they are less familiar with the transportation facilities at the destination. So public transport interchanges in this case are a burden on tourist experience and modal shifts. However, what we see here is that the behavioral response of tourists to intermodal public transport has not been assessed yet, as far as we are aware. So, and this is the gap that we try to bridge in this with this research. So the research focus is again studying the preferences of tourists in Hong Kong through a discrete choice experiment. And in particular, we are proposing in this presentation two studies. The first one, we modeled the tourist choice, and we try to assess some policy scenarios, so some what if scenario. And in this context, we look at the key transport attributes, being travel time and travel costs. And we also look at two particular attributes that are related to tourist use of public transport. And this is the information provided during the transport journey and the characteristic of tourist attractions. Of course, we shouldn't forget that tourists are incentivized to visit an attractions also based on the characteristic of the attraction itself. In the second study, we want to investigate the preferences even further, and we try to explain the heterogeneity in preference by looking at differences across tourist characteristics. So before getting into the research design, as we have more time for this presentation, I wanted to give you an overview of the destination we are talking about and the method that we are using. So Hong Kong is relatively small territory. Its territory is 86% has the Rome territory. So it's similar to Rome. Or if you are more familiar, well, in blue you see the territory, the area of Rome, and in red you see the territory of Hong Kong. Or similar to the province of Pescara. I know probably you're more familiar with this. So we are talking about a relatively small territory. However, the urban development has been is concentrated in roughly 25% of the land, and this is due to the geographic conformation of the territory. So if you think about Hong Kong, probably you don't think about green areas, but we definitely have a lot of green in Hong Kong, and the urban development is squeezed in 25% of the territory. We are roughly 7.5 million people in Hong Kong. So in terms of attractions, these are the most popular attractions in Hong Kong. What the map here, can you see the map? Yeah. Maria Giovanna, can you see the slide? Yeah. Right. The map here is taken from a publication, Lau and McKirch in 2006, and you can see the tourist attractions in Hong Kong, and you see that the majority of them are concentrated in the urban area, the Hong Kong Island and the Kowloon side. However, you see that there are many peripheral attractions. Now, if we look at the main attractions, well, what you see in the picture is one of the highlights in Hong Kong. So the skyline, the harbor view, and of course the skyline at night time. We do have a light show here going on every night and attracts a lot of tourists. So a lot of built environment is part of the main tourist attractions. We do have some botanical gardens as well. Two main attractions are theme parks. The one in the picture is called Ocean Park. The other one is Disneyland. Disneyland has its very own metro line. Instead, Ocean Park has a stop in a metro line. And of course, we have also culture and temple, and of course, you don't see pictures here, but there is a lot of tourism related to shopping. These attractions attract the majority of tourism. So in 2019, roughly 50% of tourists engaged in sightseeing attractions. Now, we do have peripheral attractions too. And it looks very different. This is what it might look in rural area, Hong Kong. So very low building, two-story building, a lot of nature, and temples that are beautiful and unexplored. And you might be surprised, but we do also have beautiful beaches and sea environment. These are all taken in Hong Kong, and these attractions attract roughly 5% or less visitation in 2019. However, we do see some distinction between markets, and this is like introducing the element that there is an heterogeneity in the preferences across different markets. We will discuss this later. In terms of transportation in Hong Kong, well, the mass transit railways, the MTR or metro, is the main means of public transport. And you see that it has a very extensive infrastructure, however, does not reach throughout the whole territory, of course. The metro company is promoting, as you can see in the picture, is promoting a model shift, like a intermodality in transport by promoting lower fare by using the metro and the green minibuses. Well, in fact, in Hong Kong, we do have the main bus, which is a double-decker bus. This is what you see in the picture. In Hong Kong, there is a very interesting technique to guide people through different bus lines. And what you see in the picture is a distinction between two bus lines. And so we have markings on pavement that are guiding residents and tourists through specific bus numbers. So very efficient. So the metro system and the bus infrastructures in Hong Kong are very, very efficient. Bit less efficient is the minibus, the green minibus, or depending on the region, you have different color. This is an example of minibus, usually are accommodating like 16 or 19 people on board. And as you can see in the picture there, the stops for the minibus are very much less user-friendly. So tourists usually are not familiar with this minibus system and tend not to engage with this means of transport. Taxi are very popular in Hong Kong and also convenient if we compare the fare of taxi with other urban destinations. There are many, and they are available throughout the day. Taxi are very efficient too. This is a picture taken like a few days ago. I challenge you to see how many smartphones this taxi driver is using. You might want to tell me at the end of the presentation. So that was a bit of the introduction for the destination. Now, the method that we are using here is related to discrete choice analysis. So discrete choice analysis is a technique used whenever we are facing a choice among a set of alternatives. And imagine that we are facing these kind of choices many occasions. When we are choosing a destination, where we are choosing a means of transport, when we are choosing a specific hotel, when we're choosing an attraction. So whenever we do have a set of mutually exclusive and collectively exhaustive alternatives, then we are in this methodological context. We describe alternatives by a list of attribute values. So we describe alternative with a vector of attributes, and each attribute has its own value. We apply a decision rule. So we assume the decision maker being an individual, a group of people, or a firm, to evaluate each alternative on the basis of its characteristics. And the decision maker choose accordingly. Now, if we assume the utility maximizing behavior, then we expect the decision maker, a rational decision maker, to choose the alternative that gives the greatest utility. So the random utility theory is underlying this technique. And of course, we are not able to represent the decision rule in its entirety, but we can approximate up to a probability. We are not able to observe all the factors that affect people's choice. So we can do this up to a probability. So we define the probability of a specific alternative being selected if the utility associated with that alternative is greater than the utility associated with other alternatives. So there are two main types of data used in discrete choice analysis. The first one is revealed preference data, and this reflects choices made in real situation. The other method is static preference data, and these refer to choices made in hypothetical situations. In order to collect static preference data, we need to develop a discrete choice experiment. Now, if you think about the benefit, the advantage of the static preference data in comparison with revealed preference, well, we can list several advantages. The main, in my opinion, is the ability to investigate products or features of products that are not present in the market yet. So imagine that we want to investigate a new transport service. We cannot collect revealed preference data. And so we need to rely on static preference data. That's exactly what we want to investigate in this research. We want to understand how people react to specific situation, and we want to be able to control the level of the attributes describing the alternatives. So we develop a discrete choice experiment in this research. The construction of a discrete choice experiment mainly involved coming up with a combination of attribute levels describing each hypothetical alternative. The more attribute and attribute level you have, the higher the number of combination. So you need to come up with a sort of extraction of the among all the possible combination. One method, one technique is the orthogonal designs. Orthogonal designs assume that the coefficients in the model are equal to 0. The other method is called efficient design. Here, within the efficient designs, the model estimates are not assumed to be equal to 0. So it gives an advantage. However, while they perform better than orthogonal design, they do require prior knowledge on the model estimates. Again, because in efficient design, the assumption is the model parameters are not equal to 0. So prior knowledge is required. These are two examples for discrete choice experiments that are taken from my two of my paper. One, in this one, you see 3 alternatives, and they are labeled alternatives. So there is a distinction between labeled alternative. In this case, you have road, combined transport, and another alternative. And in this other experiment, you have unlabeled alternatives. So you have a given hotel A, hotel B, and hotel C. The number of alternatives that you put in the choice experiment depends. Well, if you have a label alternative setting, then you have a defined number of alternatives. Otherwise, you can go with 2, 3, or arbitrary chosen. The estimates from a discrete choice model provide information on the preference structure. So because it's based on random utility theory framework, the coefficients of a discrete choice model represent marginal utilities. And the estimates, the marginal utilities, enable the derivation of additional indicator related to preference and demand. So the willingness to pay or marginal rates of substitution, so the ratio between 2 marginal utilities. And choice probability and demand indicators like elasticity or what-if scenario. So these willingness to pay and choice probabilities for the assessment of what-if scenario are going to be used in this research. So the design of the research, we do have run a preliminary qualitative analysis, and this was targeting the confirmation of the attributes in this specific context. So we ran in-depth interviews with 9 travelers which had experience with the intermodal public transport in Hong Kong. The results confirm the importance of the travel time and the importance of information when selecting intermodal transport. So of course, we take this information and we design the choice experiment accordingly. In terms of type of attractions, we see an interest in cultural and to a lesser extent in natural attractions. The discrete choice experiment involves, again, the setting up the alternatives, attributes, and levels. Here we have 4 alternatives. 2 alternatives are related to the intermodal transport. So again, we have the metro. We assume that the first leg of the intermodal transport is performed with the metro. Why? Because hotels are mainly located throughout the metro infrastructure. So tourists usually have very easy accessibility to the metro infrastructure. So we assume that the first leg is the metro, and then either bus or minibus, based on the transport offer we have at the destination. We use 5 attributes to describe these alternatives: travel time for the first and the second leg, total cost, and the two attributes associated with information. Again, we know how important is information for tourists. So we split the information into 2 components. One is the information at the interchange, so the connecting transport. You can have either no information, a generic map, a detailed map, or markings on pavement, as I showed you before. Highlighting, we have 3 attribute levels: no information, next stop on screen, so a monitor displaying the next stop, or announcement throughout the speaker. Then we have a third alternative, which refers to the taxi. And the taxi is specified with respect to travel time and travel cost. All the levels that are selected for these alternatives were considered based on the geographical territory in Hong Kong, and based on the average travel time and travel cost to reach different attractions in the destination. So this to make the alternatives as realistic as possible. We also included a 4th alternative, which is a opt-out alternative, so a no option, or what we call it here, no visit alternative. So the respondents were able to select this alternative if none of the available alternative was satisfying. Then we have scenario attributes. Again, we know how the characteristics of the attractions is important for tourists to decide whether to visit the attraction or not. So we define the attraction based on 2 attributes: the type of attraction, so we distinguish between nature and culture, and the rating of the attraction. And here we distinguish between top 10 attractions on TripAdvisor, top 10 attractions on the official DMO, Visit Hong Kong. Then, and this is the distinction we were discussing at the introduction, the user-generated ranking and the attractions promoted by DMO. Then we have trended attractions, and this is in response to the effort for DMOs in different regions in the world, including Hong Kong, to try to promote as much as possible other attractions. So we included that attribute level 2, and then off-beaten attractions on unconventional sources, so promoted from online blogs or magazines. So the discrete choice experiment was followed by 2 questions. The follow-up questions were concerning the selection of intermodal transport alternatives. So if the intermodal transport alternative was selected, a follow-up question asking about the comfort level, how easy it would be for the visitor to select the option, to use that option, and to model this this question, we had an ordinal scale, so from very difficult to very easy. If the respondent selected the no visit alternative, we wanted to understand if it was because it was not interested in the attraction or because it was not convenient, the transportation offered in the hypothetical scenario. So we asked the follow-up question whether it would be willing to visit the attraction if a direct public transport was available. And this is a yes or no question. In this slide, you see an example of choice card. So probably you can connect more the dots here. We have 4 alternatives: the mainstream minibus, mainstream bus, taxi, and no visit. You see the list of attributes considered for the 3 transport options. And then you see the scenario attributes on the top. And you see that those scenario attributes are invariant across the different transport options. So they define the scenario. And you see that the 2 follow-up questions are available, whether the respondents select the intermodal transport or the no visit option. In order to facilitate the comprehension of the experiment, we provided the respondents with 2 additional information. One was a card showing the alternatives available, and here you see the 4 different means of transport. And the other card was showing the information for the interchange. So we had a generic map, we had a detailed map, and you see that the detailed map is very detailed. This is a picture taken in Hong Kong, so that's a real map showcased in a metro station in Hong Kong. It might be a bit difficult to navigate that map. And then we modified the markings on pavement. While we understand that this approach is a very valid approach, but we wanted to understand whether we could improve it by adding specific information for the attraction. So not just the marking with the number of the bus, but the marking with the name of the attraction. So even more tourist friendly. The experimental design was based first on a pilot survey. And again, we are using efficient design, so we needed to have prior information about the model estimates. And of course, we also wanted to test the consistency of the survey. So we ran a pilot survey with 50 respondents, and we used an orthogonal design. So no prior information was required. Collected the information, we estimated the model, and we fitted the efficient design with the model estimates from the pilot data. And we designed 12 choice tasks representing different combination of attribute levels. Now, the questionnaire included also other questions, and it would have been too long for respondents to face 12 choice tasks. So we decided to split the 12 choice tasks into 2 blocks. This is a common practice in this method. So the 12 choice tasks were split in 2 blocks randomly, and each respondent was randomly allocated to either the first or the second block. So each respondent faced 6 choice tasks. The survey was conducted among tourists in Hong Kong, and the target population was individual inbound tourists. Why? Because we wanted to screen out tour groups, because mainly they travel with the private transportation mode. And we wanted also to have in the population the tourists that were familiar with the local metro, so at least they had used it once. The questionnaire included 3 sections. the information on the current visit, the discrete choice experiment, and the tourist profile and perceptions. This survey was conducted by a research assistant and in main tourist areas, and collected 516 valid observation in the last summer, 2019. So the first study model, it's modeling tourist choice. So we have the choice experiment, and we want to estimate marginal utilities, willingness to pay, and choice probability, because we want to assess different policy scenarios. We want also to investigate the two follow-up questions. So we have the ease of travel with the intermodal transport, and whether respondents would visit the attraction if a public transport direct link was available. So this is the conceptual model. You see that we have a discrete choice model based on the attributes and alternatives. Then we have the follow-up questions that we assume to be explained by the level of ease by the attributes in the intermodal transport options, and also the information that are used to navigate, to go around in the destination. Instead, the availability to visit the destination, if a transport link, direct transport link was available, we model it with respect to the traction characteristics and the motivation of the tourist. So we have these three sets of three models. The first choice experiment is modeled again with respect to the utility theory. So we have the utility for a given alternative specified as the observed part, so the systematic part of the utility, B, and a error term, so what we are not able to observe. And this, the systematic part, is a function of the attributes describing the alternative. Now we have 4 alternatives in this experiment. So we have a system of 4 utility. The two intermodal transport, the taxi, and the no visit. Now the alternative specific constant can be introduced only in J-1 alternative. Only difference matters in this method. So we normalize the no visit to 0. The categorical attributes, so the information at the interchange and the information in the highlighting, were categorical, so have been dummy coded. And the reference category was no information. The scenario attributes are invariant across alternatives, so they cannot be entered in each utility function. So they are entered only in the no visit utility. And again, they are categorical variables. So the reference category for the type is nature, and for the rating is top 10 TripAdvisor attractions. Okay, we model the choices with by using a mixed login model. The mixed login model accounts for unobserved preference heterogeneity, so random heterogeneity, and correlation across choices. Remember that we have 6 choice tasks per respondent. So it's fair to assume that a given respondent has a correlation across the responses, the 6 responses that give. So we want to take into consideration that. So the mixed login model allows us first to accommodate preference heterogeneity, random preference heterogeneity, by specifying the coefficient as a function of mean coefficient and a standard deviation. So for each attribute, for each coefficient, we estimate a mean coefficient and the standard deviation coefficient. The standard deviation is associated with a specific distribution that can be selected by the analyst. Typically, it's normal distribution, but other distribution has been considered in the literature. Here we use normal distribution. Considering a Gamble distribution for the Herald term, we have this logit expression for the probability. And you see that the product in mass represent the pseudo panel data. So we have 6 trig tasks per respondent. Now, this integral has no closed form. So the estimates are, the estimation of the model parameters are relying on simulated maximum likelihood procedure. And in this case, we use 2,000 draws to simulate the log likelihood. Now, the results for the descriptive statistics, we see that the no visit option has been selecting 14% of time. And the most popular was the combination between metro and bus. With respect to the 2 follow-up questions, we see that those tourists that selected the intermodal transport options were quite confident in handling this transport solution. So roughly more than 65% of respondents stated that the selected transport option was either easy or very easy. It's interesting to see that for the follow-up in the no visit option, a great majority, 62% of respondents stated that they would visit the attraction if a direct public transport was available. In terms of information source and motivation for the trip, we see that the smartphone is the main device used for to get around at the destination. However, we see a small percentage of people asking locals and using paper maps. Motivation, culture, and nature are the dominant motivation for this destination. Now, in terms of results, what we see here, this is the result for the discrete choice model. The alternative specific constant, again, they are normalized with respect to the no visits. So they're positive. So there is an overall preference in visiting the attraction. Now, if we look at the culture, the type of attraction, the coefficient associated with culture is negative. So it means that if the attraction is a cultural attraction, then there is a lower probability of selecting the no visit option. And this is in line with the general tendency to prefer cultural attractions over natural attraction. If you look at the rating of attractions, there is a higher probability of visitation for top rated attractions promoted in DMO compared with those promoted in TripAdvisor. And there is a higher probability of no visitation for trendy and off-beaten attractions. As you see, the coefficient associated, the mean coefficient associated with trendy and off-beaten are positive in value and significant, meaning that being trendy and off-beaten attractions increases the utility associated with the no visit option. And this, of course, it's what we expected as well. In terms of transport-specific attributes, so travel time and travel costs, we see that there is a higher sensitivity to travel time in the bus or minibus than metro. The value of travel time saving is the willingness to pay indicator when we have travel time with respect to cost. So respondents are willing to pay $15 cents US dollar per minute saved. So to save 10 minutes in the bus journey, respondents are willing to pay an additional $1.5. Similar sensitivity towards public transport and taxi fare. If you see the coefficient associated with the intermodal travel cost and the taxi travel cost, you will notice that they are very similar in magnitude. Now, in terms of the information provided at the destination, well, we see that generic maps are preferred over detailed map, while direction marked on the pavement provide the greatest utilities. Again, the coefficient associated with marking of pavements, it's positive and significant. So providing higher utility to respondents with respect to no information. Somehow surprising that the detailed map is not preferred over generic map. And this is, again, probably related to an overflow of information available in the detailed map. So this is a point to consider for the destination. In terms of aligning information, the preference for speaker announcements and to a greater extent display visual information as opposed to no information. So there is indeed a willingness to get information when it's time to alight. Now, after the estimate of the model coefficients, we wanted to look at the scenario. So how the probability to select different alternatives changes if we consider specific characteristics of the attractions in this case, or the transport in the following slides. So what you see here is the share, the probability, the percentage of tourists selecting each of the 4 alternatives if we consider the nature attractions or a cultural attractions. So for example, if we consider natural attractions, we see that the percentage of no visitation increases to roughly 18%. So the share for no visit would be 18%, as opposed to 11% for cultural attractions. And again, here we see the general tendency to prefer cultural attraction than natural attractions. Very striking preference for highlight attractions. So nearly every tourist would visit an attraction listed in the top 10 rankings, either TripAdvisor or DMO. On the other hand, there is a very high share of tourists refusing to visit attractions that are either classified as trendy or off-beaten. So here the share for no visit increases to almost 30%. Now we see that if we focus on the taxi alternative, we see that there is some rigidity in the share. So the redistribution that happens, for example, when we look at the different scenario, is mainly involving the intermodal transport option. The share for the taxi alternative always remain around the original share. So the baseline scenario, around 50%. Now, in the second set of choice probability, we wanted to look at the changes in the transport-specific attributes. So in particular, we looked at a reduction in travel time for the bus or minibus equal to 20% or 40%. Again, there wouldn't be much meaning in reducing the travel time in the metro line or increasing the travel time. So we wanted to focus our analysis on a reduction on the second leg of the intermodal transport service. And then we consider a scenario where we increase or decrease the taxi fare by 20%. Now here, what we can see is that a 20% decrease in minibus travel time leads to an increase of 4.4% in demand. So the gain is mainly distracted from the other intermodal transport mode. You see that 3.1% has been distracted by the bus alternative. A decrease in the travel time of the bus ride makes the combination between metro and bus particularly appealing, and this would result in a reduction of the no visit option by 2.2%. So this is more interesting in terms of policy implication. So we have a decrease, consistent decrease in the no visitation if we decrease the travel time of the bus ride. In terms of taxi fare, we notice that a decrease benefits the taxi alternative more than what an increase does. So we have a very marginal contribution on the no visit option. So this is something to consider for the taxi alternative. Now, with respect to the two informations that we provide at the transport connection and alighting, well, we see that marking on payments mostly benefits the bus option and would generate extra demand to peripheral attraction. So there is a decrease in the no visit by 3.7%, which is quite promising. Instead, in terms of our lighting information, well, we see that in-vehicle screens or announcements will significantly benefit the metro and minibus intermodal link. And this has to be considered by recognizing that the minibus alternative at the moment does not provide any alighting information. So there is no information whatsoever. So there is no screen, there is no announcement, and it's very unfriendly also for residents. So that's something to consider for the minibus company if they want to be more tourist friendly. Now, if we look at the results for the two follow-up questions, so we have the level of ease when the intermodal transport option has been selected, and we explain this with the transport attributes and the information source of the destination. So we see that the level of ease decreases as travel time and travel cost increase. And again, this is in line with the expectation. The longer the journey, the more expensive the journey, the more difficult it is to engage with it. The provision of connecting information does not appear to contribute to the level of ease. So that's also something that needs to be considered. Instead, if we look at the alighting information, we notice that having announcement through the speaker would increase the likelihood, the probability to select very easy as an option in the level of ease by 9.1%. So definitely, this is something that should be considered by transport stakeholder. In terms of information source, it's interesting to see that based on tourists that rely on paper, so either the paper-based map, then we have an increase in the level of ease associated with those tourists that rely on smartphone, and especially local people. So there is a tendency to highly evaluate the help from local people, especially in a destination where the language could be quite of a barrier. Now, the second follow-up here we modeled the follow-up question in relation to the visitation if the direct transport link was available. So we see that the main part here is associated, the main market is associated with the trendy attractions or off-beaten attractions. Again, the majority, the great majority of respondents, of tourists, would visit the attraction if it is a top attraction. Compared to off-beaten attractions, a trendy attraction has a higher probability, 10% higher probability to induce visitation intention if a direct public transport link is available. In terms of motivation of tourists, well, we see that the higher the interest for cultural and nature attractions, the higher the probability to select to visit the attraction if a direct public transport link was available. Instead, an inverse relationship is noticed for people that are interested in shopping. And this is also in line with expectation. Now, what are the implications? Well, the implication for these studies are several. We divide them into 3 categories. So the DMOs should nudge tourists. We find that there is an importance of type and rating of peripheral attractions, and there is a high importance for must-see attractions. So what we propose is to, again, nudging tourists by selecting some peripheral attractions and placing them in the must-see category, and rotate them according to thematic or natural season. So this would allow some peripheral attractions to benefit from this top attraction promotion. In terms of metro, we see that there is a very high importance for the marking of payment and simple maps. So here we can incentivize the use for clear direction and connectivity between transports. In terms of local buses, well, we can find a list of implications here. Travel time is very important. So we probably need to find those lengthy bus segments and design shorter routes, catering mainly for tourists. We definitely need to improve the information in vehicle, so especially for the minibus, which at the moment, again, do not provide this kind of information. The direct public transport is something that is highly considered as a value for respondents. So we probably need to consider establishing new transport services, collecting tourists around the main hotel areas and directly going to tourist attractions in the peripheries. We do have in Hong Kong very similar services for the airport. So there is the airport link, which does a very similar concept. So something similar could be established. And again, let me stress out that in this analysis of the implication, the results of the model provide a clear indication in terms of the propensity to pay, the willingness to pay, and the demand. So once we have this information, we can assess the convenience, the profitability, and the implication of establishing a very specific bus route or adjusting an already existing bus service. Now, very briefly, because I was not aware of this 1 hour cut time, I was aware of 1.5. I will go through the second study explaining the preference heterogeneity. From the literature, we do know that tourist aspects affect movement patterns and the use of public transport. So travel characteristics, for example, familiarity with the destination, whether it's the first time or is a second or more time that the tourist is visiting the destination, and the length of stay, these characteristics affect the itinerary of the tourist through the destination. And we also know that the attitudes and perception affect the use public transport. So in this study, we want to explain tourist heterogeneity by using observed variable, length of stay, and familiarity by estimating a mixed logit model with heterogeneity mean, and including latent variables, so perception of tourists towards public transport at the destination, and environmental concerns. So these kind of latent variables can be used to explain the preference heterogeneity. And this, in order to model these variables, we are estimating a hybrid choice model, which is formed by two components, mixed logit model and latent variable model. You see it here in grayish because I didn't plan to discuss it in this presentation. The approach to the model, it's a little bit different than what we are using here. So it would require an additional session to discuss it. But I'm very, very happy to discuss this later with you if you're interested. Now, if you recall the conceptual model we had before, so we have the discrete choice model, the attributes of the transport and the alternative, the utility and the choice and the four alternatives. Now, in this study, we introduced these two travel characteristics in order to interact in order to explain the preference heterogeneity for the attributes. So you remember we have the coefficient that is it's like a combination of a mean value and the standard deviation. Now, this model extends the formulation, formulation of the coefficient by introducing a list of observed characteristics. Again, here we have two, we could have more. So in this case, each attribute is specified with respect to a mean value, the interaction with travel characteristics, and the standard deviation. Now, the two variables that we are considering here are length of stay, binary variable, short stay, 1 to 3 nights, and long stay, 4 or more, and familiarity, so first time and repeat. As you see from the table, roughly 80% of the respondents were short stay, as expected, and 80% were visiting Hong Kong for the first time. These are the results for the choice model. I broke down the table into 3 sections to facilitate the display, but it's the same model. 3 tables refer to the same model. So what we can see here now, for each attribute, again, we have a mean coefficient, the standard deviation, and the 2 interaction, long stay and repeat. So we can make a discussion here on the influence of length of stay and familiarity in each attribute considered. So in terms of long stay, we have a higher preference for attraction listed on TripAdvisor compared with the DMO. In terms of repeat tourists, there is a lower preference dominance for attraction type. So again, remember that culture was negative, so there is a lower probability to select the no visit if the attraction is a cultural attraction. Now, if you see the coefficient associated with repeat stay, it's positive, meaning that this negative effect is diminished, in this case by 1.5. So the repeat tourists value very similarly the natural and cultural attractions. So there is a higher interest for natural attractions compared with first-time tourists. And again, this could be related to previous visitation of cultural attractions and willingness to expand the knowledge of the destination. There is a lower preference dominance for attraction rating as well. So there is, if you look at the trendy attractions, we see that repeat stay has a negative interaction. So the higher probability to select the no visitation if a trendy attraction is concerned is reduced. So the assessment of the rating is more balanced towards trendy attractions. So there is a higher preference, higher interest in trendy attractions compared with first-time tourists. Now, with respect to transport-specific attributes, long-stay tourists are less sensitive to public transport travel time and travel cost. Probably because they stay longer, so they have a lower sensitivity towards travel time. Repeat tourists, on the other hand, are less sensitive to the bus or minibus travel time and more sensitive to taxi travel time. You see that the interaction is negative, so it's going to be even greater sensitivity for the travel time. Now, it's very interesting here to notice that for the travel time in the second leg of the intermodal transport, we have a distinctive, very distinctive categorization in terms of sensitivity. So if you see that the main effect is significant and also the two interactions. So we have a differentiated effect across the four groups of tourists. So we have a short first-time visitors that have a higher sensitivity towards the travel time in the bus segment, followed by long first-time visit and short repeat visit, and finally the long repeat visit. So long repeat visit have a lower sensitivity towards travel time in the bus segment. We can reflect this into willingness to pay. So again, the ratio between the marginal utilities, so the value of travel time saving for the bus and minibus segment. And we see this is expressed in US dollar per minute. So we are going from a 1.7 US dollar per 10 minutes travel time saving for short first-time visitors to 0.4 US dollar per 10 minutes saving in the second leg of the intermodal transport for long repeat visit. Now, with respect to the information at in the transport, well, we see that repeat tourists are less sensitive to alighting information. Again, probably because they are more familiar with the destination. Long stay tourists instead are less sensitive to connecting information. Probably they stay longer because they stay longer at the destination. They are less concerned about spending time in finding the right connection, and they're less sensitive to alighting information, probably for the same reason. Now, it's interesting here to see that the same distinctive categorization that we have noticed for the transport-specific attributes is also found for the alighting information. So we have the four groups, and we have a different sensitivity towards the information, the alighting information. Short first-time visit plays a very high value to alighting information, whereas long repeat visit plays a lower, relatively lower value to alighting information, and the other two groups in between. Now, what are the implications here? Well, we see that there is a differentiated effect of length of stay and familiarity. So familiarity affects tourist preference for attraction type and rating. So irrespective of the length of stay, repeat visitors show higher interest on natural attractions and trendy attractions. And again, here we have a market for repeat visitors in terms of natural attractions and trendy attractions, that are those attractions that are less interesting for first-timers. In terms of length of stay, we see that this aspect affects tourist preference for the information between transport modes.
Sorry, Lorenzo, we have no more than 5 minutes.
Yeah, that's more than enough. The key implication from these studies is the distinctive segments that are identified by these two key observed variables. So we have a very high sensitivity for travel time and information, alighting information for short first-time visitors, a medium sensitivity for long first-time visitors, short repeat visitors, and a low sensitivity for long repeat visitors. So let me conclude by saying that in this research, we attempted for the first time to model the intermodal transport choice of tourists for peripheral attraction visitation. So we have done a trade-off between attraction-specific and transport-specific attributes, and we believe this is a relevant contribution to the theory to the stream of research looking at tourism and transport at the destination. We have also investigated the impact of transport attributes on the level of ease in using intermodal transports at the destination. And we have assessed the role of direct public transport for attraction visitation. This has been analyzed by looking also at preference heterogeneity. So we derived marginal utilities and willingness to pay to guide policy conclusions. So we know how important it is to create impact for the community, and what we expect this research to provide. Well, at the tourist level, we aim that the research would enrich tourism experiences. The urban destination, what the impact is on strengthening the tourism offer and eventually contributing to decongesting the tourist flow. For the peripheral attractions, well, we aim to expand the demand. We hope that this research would help peripheral attractions to expand the demand. What is the next step? Well, we want to amplify the impact, and we want to look at more in detail the solutions that can be undertaken in the destination. So we are planning to prepare a list of case studies using the information we have from the model estimates, and distributing the results and reports to stakeholders at the destination. So we hope that this would leverage on the impact of the current research. With this, let me conclude, and my apologies for running out of time. I was not planning on 1 hour, but 1.5 hours. So thank you very much for your attention.
Thank you, Lorenzo, for your interesting presentation. And since we use more time for the slide presentation, I propose you to start with the questions without the 5-minute break. I invite all attendees to make questions.
Giovanna, I do have a question. I actually wrote it in the chat, so maybe people can just write in the chat if they want to actually ask something. So we have some kind of order, or just raise their hands, whatever they want.
Start with Alessandra.
Well, congratulations, Lorenzo. This is a lot of work. Clearly shows, very well presented. I do myself like the discrete choice models, although I'm not as familiar as with the mixed logic models, because I wasn't really into estimating willingness to pay. I used them for migration, but in my PhD, but it was a completely different set of data. All right, so, but as I said, I do like these models a lot because they come up with very concrete answers, which is this willingness to pay. It's something that you can really use as a policy tool, so it's really good. Again, two very good papers. What really struck a chord for me was this repeat tourism part that you showed, because I've done a lot on repeat migration, and so that for me was the most interesting part. And and here is my question. In my own work, I was giving a lot more attention to actually the choice invariant, the individual characteristic, rather than the choice characteristics, which is your approach, right? Because you are looking at the choice characteristics. And I was just wondering, is there any scope in your own research to look also at these choice invariant or individual characteristics of the chooser? Or you are not looking into it because it's not relevant? For instance, I was thinking international versus local or Chinese tourists. Maybe it doesn't really matter because you have a quite homogeneous tourist market, which I don't know because I know nothing about Hong Kong. But are you looking into, because for me, to what for what I'm familiar with, I was thinking, okay, is there a difference between young people and older people? Is there a difference between international tourists and other tourists? It's true that in your second paper, you have two characteristics which are both choice and individual dependent, because you know the familiarity is a combination of the two, the length of staying, it's a combination of the two. So, but you don't really have any choice invariant characteristics in your analysis. Is it because it's not worth it exploring it, or I was just wondering about these?
Right. Thank you for the feedback. Yeah, it's definitely very relevant to also look at the tourist characteristics. That's what we try to do in the second study. It is true that in this application we wanted to focus more on managerial implications, so to provide some like usable information for the destination. And so, of course, the more disaggregate you go, the more refined the research is, but then the more difficult it is to satisfy all the segments. So we stayed pretty much at the aggregate level, even though we look at familiarity, so first time and repeat, and length of stay. These are two invariant characteristics. It is in our plan to look more into the source market, as you suggested. Hong Kong has a very high reliance on mainland Chinese market, and also on other type of distant country. So we wanted to look at that. Eventually, what we will try to do for this mixed logic model, another interesting part is that we can derive individual estimates. So we can derive individual parameters. And then with that, we can really segment the sample with respect to invariant or tourist characteristics. And this would be more in line with what you were suggesting. Yes, we do plan that as a follow-up, but at this level, we wanted to say more like at the aggregate to facilitate policy implications.
So you'll have like a density function, a distribution, and then you will know exactly, for instance, you know, what it's, you'll segment by using these. This is what you're saying.
Right, exactly. We can, with the mixed logic model, because of the distribution and using the bias rule, we can estimate individual specific coefficients. So this has been done already in several studies. We also use this technique in several papers. And it's interesting because it really allows us to model the individual heterogeneity, so at the individual level. And so we can relate the heterogeneity with respect to these characteristics that you were suggesting. Yeah.
Okay, Ugo, do you have a question?
Here I am. Thanks, Lorenzo, for your presentation. It was interesting. I want to ask you, what about over-tourism and contribution of mass tourism to the current climate emergency, climate crisis? Your presentation focused on the issue of tourist preferences in transportation. How can we, in a way, reverse our viewpoint and see how government policy can redirect tourist preferences towards goals of related to the pursuit low carbon society? Are you concerned with this kind of more normative approach? Because I think in practice, for instance, tourists are very good. They walk a lot more than residents around the city. When I was in Hong Kong, I really walked a lot, even though the city was not very hospitable for pedestrian practice, because it's really based on cars and other kind of private transport or public transport. But so, in what kind of policy we can have? What kind of government-led adjustment of tourist preferences? You know, adjustment to use the soft word we can think of, and how this can be done in a normative sense that in a way meets the demands of expectations of tourist experience. Thanks.
Right. Thank you. I think you raised a very valid point here. Indeed, the problem with over-tourism and carrying capacity was one of the triggering point of this research. As you have been in Hong Kong, you notice how the masses are crowded towards specific points. And so there is a concern in terms of carrying capacity, destination capacity, and there is also a concern in terms of conflicts between tourists and residents for the usage of public space. So there are some research going along this line. And one of the triggering points for this research was exactly that one. So how about we try to make peripheral attractions more accessible, so that we understand that if you come to Hong Kong for the first time, you still want to see the main attractions, right? But maybe we are able, by improving the accessibility of peripheral attractions, we are able to somehow shape the tourist flows towards those attractions, and so that the main attractions would result a bit less congested. And so that was one of the triggering points. The other point, what you mentioned, is also very, very interesting, like the environmental concern. So Hong Kong relies very much on taxi. Like, as I said before, taxi here is very popular. So we introduced in this research, we introduced a set of questions, especially related to environmental attitudes, because we wanted to investigate whether the environmental concern would trigger the usage of public transport instead of taxi. At the moment, we have introduced this because it's a latent construct. So we introduced this in the hybrid choice model. I didn't present it here. So we see a connection there. But the current situation is that to reach certain peripheral attractions in Hong Kong, it really takes a long time. So it's roughly, like, say, 1 hour, and with the taxi you can reach the attraction with 20 minutes. So there is a sort of imbalance and the high popularity of taxi. So that's why we try to propose with this research, like, dedicated transport services for these attractions, also in relation to trying to be more attentive to the environmental concern. So yeah, it's definitely a spin-off of the research that will be considered in more details. Yeah.
Grazie, Lorenzo. Thank you.
I can see other questions from the audience. So I make a question. Your results are based on interviews done in the summer 2019, is right? But after this pandemic crisis, this recent pandemic crisis, everything in tourism is changing. We know that tourism is one of the most affected sectors by this crisis. And in particular, I think that public transport will be substituted by private transport because considered safer. So what do you think about this possible scenario, and which will be possible implications in a small area like Hong Kong?
Well, that's a very good point. Well, we are considering this. It's true that people tend to use private transport more. However, we see, in this sense, we see a lot of potential in the minibus alternative. Again, the minibus is not as big as the metro, is not as big as the double-decker bus, but only 15 people are served in each minibus. So again, it can be envisioned a bit more like a sort of private, like a combination between private and public, right? So I personally think that there is a lot of unexploited potential in this alternative. They run with a very high frequency. Again, like in terms of travel time, they're able to approximate or to get more closer to what is the travel time of private cars. They're smaller. So if we really design, like the minibus alternatives for specific peripheral attractions, these can really be one of the added value of the transport service in Hong Kong. In terms of the global pandemic, well, it is true, and we do believe in our research. We hope that one of the messages that we transfer is that don't just limit on yourself on the sightseeing attractions. So there is much more to see, and there is much more that the destination has to offer, even though it is a urban destination. We see that living in Hong Kong for 8 years, sometimes we don't even know, we don't even are aware of the existence of certain peripheral attractions. There is a lot of attractions that are unexplored. So we do hope that also in these current times with the pandemic, that the travel has been very much restricted within your own borders. We hope that our research also helps to spread awareness on the unexploited potential associated with peripheral attractions. There is a very interesting line of research which I'm considering in another research project, which is the Great Bay Area. In Hong Kong and the southern part of China is opening the Great Bay Area. So it's unifying 9 major cities. This region will be composed of roughly 70 million people. It's one district, it's one Great Bay Area. So it will be the greatest Great Bay Area in the world. So, and there is a lot of research going around here. So we plan, from my point of view, I'm looking at how transportation facilitates tourism within and across this area. Because at the moment, the majority of tourism in Hong Kong is very short. You see the length of stay is very short. The format of tourist is in between the destinations. So it's a stopover. Instead, with this Great Bay Area, it might be Hong Kong a part of the main destination itself. So, And of course, the more main destination visit we have, the higher the length of stay, and the more time tourists might have to visit a greater extent of attractions. So that's also a line of research. And with the pandemic, of course, yeah, we are all confined. So of course, we do hope, and I'm still positive, that we will be able to travel in the near future. But that's a possibility that we are considering. Yeah.
Thanks, Lorenzo. I don't know if there are questions from the YouTube channel.
I have a curiosity, not a question, really.
Thank
May
you.
I?
Please.
Lorenzo, thank you very much for your presentation. I have just a curiosity, which is in part related to the intervention of Ugo and Giovanna. I was wondering about the policy related to the bike lane. This is to say that maybe I lived in Paris in a metropole, and I was a commuter and a tourist at the same time. And my urban experience riding a bike was really different and higher than that traveling by tube, for instance. So I was wondering if on the Hong Kong city, I guess that it is difficult to reach peripheral areas by bikes. Also, if we have electric bikes, which are really changing the possibility to visit, to travel in urban areas. But I was wondering about the policy of Hong Kong related to the soft mobility and the use of bikes.
Yeah, in terms of use of bike, we do have certain districts that have bike lanes. In the main districts, there are no bike lanes, mainly because of the traffic, but mainly because of the natural setting. So Hong Kong is not flat, so it's very hilly, and there are like quite some steep roads to climb. So it wouldn't be even like feasible to place bike lane in the central area. But there are districts with this possibility, and at the moment are mainly utilized by recreational purposes. So residents using them like in the weekends, or there are some companies that are renting, but there is no bike sharing, for example, like in Europe. So the offer is very limited. There are some rental companies that rent the bike by hours, but it's mainly used by residents, and for tourism purposes, probably would be a bit complex to design bike lane spreading throughout the main attractions. Of course, in those districts that it's available, it would be interesting to look at it in more detail and consider whether tourists would be willing to explore that possibility. Yeah. Thank you.
Thank you, Lorenzo.
Lorenzo, I have a very small comment. Thanks for your presentation. I want to focus just on one small thing of your heterogeneity analysis. Not just to criticize, because it is a kind of follow-up question everyone has whenever you see a presentation of discrete choice. So, oh, what about heterogeneity? And I happen to be a very close colleague to one of the leading scholars in this. Is I don't know if you have read from him, from Riccardo Daziano. Is from Cornell University. So he has a lot of very interesting papers that tackle the issue of heterogeneity. I was lucky enough to know him and to work with one of his close co-authors. And so they because it's kind of they also have these types of choice experiment models applied to electric cars, applied to transportation choices. So So I wanted to know if some of your heterogeneity analysis will also be spun off into a paper related to what they are doing. They often see how preferences are heterogeneous, what implications that it have, the methodological challenges. I kind of follow the literature. I'm not a specialist myself in those, but I wanted to know how you could probably expand your heterogeneity analysis using these kinds of tools. And thank you.
Right. Yes, as far as I remember, Ricardo does a lot of, one of the main research stream he does is on the hybrid choice model, so modeling the latent variable. And that's exactly what we are trying to do in the second study, explaining the heterogeneity with the latent variable. Again, I haven't presented here for interest of time, but that's the stream, that the line of research we are taking. Of course, I'm a bit like putting myself in between. Explaining heterogeneity also with latent variable, but also trying to give practical information to stakeholders, to decision makers at the destination level, because we know that the more refined your explanatory of the preference heterogeneity is, especially if you look at the latent variable, then you might have different set of impacts. So in this specific research, we were more looking at trying to tackle managerial implications. In the second study, definitely we are going on that line, and we do see the potential for explaining heterogeneity, both by using what also Alessandro was suggesting. So invariant, so tourist characteristics, so observable characteristics, but also latent variables, so perception and attitudes. So this is the line we are undertaking, and I also see very many similarities within the explanation of heterogeneity we are trying to propose in this study and the studies that Ricardo is conducting on more like transportation choices.
Thank you, Lorenzo.
So I don't know if other participants have other questions. We have 5 minutes, so I make another question for you, Lorenzo. It's a curiosity because in your introduction you say that intra-destination movement are lower investigated with respect to other tourist movement. And in my opinion, I think that this is because the unavailability of data, and also because it's really time consuming to gather this kind of data. So I think that in the future, this trend of research will move using big data or open data, such as mobile or GPS data, because with this kind of data, we can have a lot of information of intra-destination movement of tourists. So what do you think about this kind of data, and do you think it would be interesting to study tourist behavior by using this data?
Mm-hmm. Yeah, that's a good point. There is indeed a lot of research coming up with intra-destination movement pattern using mobile and big data. And I do look at this research with great interest, in the sense that they are really helping to understand how tourists move around the destination. Now, in my perspective and in my research line, I'm more interested in providing like policy measures. So to understand how the demand, like travelers, are responding on specific stimulus. So the observation of the movement is definitely helping us to set the framework and to set the base where to study. But then in my research interest, I'm more looking at what we can do to change or to shape the demand, or what happened to the movement patterns if we introduce a sort of shock or innovation or a new product, for example. So in this context, like discrete choice models are really fitting the purpose. So we have experiments when we want to investigate the impact of a new feature, a new product. So think about whenever we introduce an innovation or something that is not available in the market. So of course, big data in this case can help because it's not available in the real market. So we need to rely on experimental research. So this is the line of research I'm particularly interested in, especially in relation to intra-destination movement patterns. So yeah, I hope that addressed your question.
Yes, thank you very much for your answer. And I think we can conclude here the webinar because I can see other questions. So I kindly thank Lorenzo for this really interesting talk. And we can conclude here this webinar. I invite all participants to follow us also for the next meeting of the GSSI webinar series. Will take place next week, Wednesday, 28 October at the same hour, with Carolina Castaldi from Utrecht University with the talk titled Innovation Measurement Beyond Patent Only, What is the Value Added of Trademarks? Thank you very much, Lorenzo, and all participants.
Thank you, Maria Joanna, for having me, and thank you, everybody, for your comments. It's been a pleasure.
Thank you. Bye.
Thank you, Lorenzo. Bye.
Thank you, Lorenzo.
Thank you.
Bye. Bye-bye. Grazie.